Okay, hello, Mr. Aaron, Mr. Ryan. Okay, so remember we talked about the parentheses. What's parentheses?
It's just like a bracket.
Bracket, okay, bracket. Parentheses, open bracket. Open parentheses, closing parentheses. So.
Did you saw that bullet?
So, do you still remember how do we check if a string contains only these two parentheses? How do we check if it match, if it's valid? What I mean valid is it comes with pairs, and this is a valid parenthesis. This is a valid parenthesis. This is not. This is not, right? This is this is not, right? Okay. So,
okay, you just need to find out. I think you're just doing like a matching petal.
Yeah, how do we find, if we're given a string, how do we know if it's a valid parenthesis or not?
We just like doing the addy and the subby.
Sorry, can you tell more specifically? So how do we check if it's a valid parenthesis or not?
For example,
yeah.
I'm gonna do one like that.
Yeah.
Okay. We're gonna do it.
Yeah.
Like that. So.
Yeah. How do we check? No, this is a valid parenthesis.
Yeah, this is a valid. Yeah.
Yeah.
That's what I said.
Yeah. How?
And then so we start from 0.
Okay, so we have a counter.
If we have one like this.
Yeah, open parenthesis.
Add 1, and if we have one like this, equals -1.
Okay, so we have a counter. When we meet the opening bracket, we increment the counter by 1, right? When we meet the closing bracket, we decrement by 1, right? And then what happens? If the counter falls below 0, what does it mean?
It's not.
It's not a valid parenthesis. And at the end, if the counter is not 0, what happens? What does it mean?
It's
not, right? For example, like that, yeah? What's the balance after this?
Wait. 1.
1, yeah. What's the balance?
-2.
-2, but when here -1, we immediately know it's not very bad parenthesis, right? Okay, that's good. Use that. What's the time complexity of this one? O what? O-N. Okay. Okay, so today's task is something similar. So given an integer n, we want to find out that how many ways we can generate a valid parenthesis contains n pairs. Remember, it's n pairs. So what does it mean? A pair, and when n equals 1, a pair is this. This is a valid parenthesis, right? So given n pairs, what does it mean? What's the length of the string in the
n times 2.
N times 2, yeah, because each pair contains 2. Yeah, n pairs, the total length is n times 2, okay? Okay, so for example, n equals 1. Easy, right? When n equals 2.
It just be that, that's for 1. And it...
Can you write the answer of n equals 2? 2 pairs. How many possibilities of the 2 pairs? Any other options?
Me, I think so.
Yeah, I think you're right. Yes, that's only good pairs. Yeah, and pairs of valid parentheses. Okay, so how do we do this? What can we do? If we don't, we can do. Can we do this? The brute forcing? Can we brute forcing? How can we brute force? The brute force is also called exhaustive. Yeah. Exhaustive search, meaning that I try every possibility, right? So how many n equals 2? So n pairs we know is n times 2 length strings. So for each string, for each character in these pairs, how many possibilities for each one? If this is n times 2, okay, this is n times 2. That's the string, yeah. So n times 2. So for each one, what's how many possibilities? 2, right? What are those 2?
Those 2.
What are those 2 strings we need to try here?
wait, what was it again?
The what?
The in the bracket. Wait.
Sorry, so the bracket. How many possibilities for each
Square
character?
brackets? 2.
2, yeah, only these 2.
That's what I was trying to say.
Okay, opening bracket and small closing bracket. Okay, opening parentheses or closing parentheses. Yeah.
Yeah.
Each one is two possibilities. So if there are n times 2 slots, how many possibilities of all these the string? If there are n times 2 slots and each slot contains 2 possibilities, so what's the overall?
Wait.
What? How do we do this? Okay,
N to the power 2 or 2.
total? For n equals 1, how many possibilities?
N equals 1. 1.
Sorry? N equals 1.
2.
2. N equals 2. How many possibilities? Here are 2. Here are 2.
4.
Yeah. And n equals 3. How many possibilities?
6.
Huh? 2, 4, what? What's next? Come on.
8.
8. Yes. And so
Oh, to the power of 2.
2 to the power of 2 times n. Yeah, that's the length. Yeah.
That's actually kind of
Big. Yeah.
yeah.
And remember, we take init n time, right, to check if it's a string is a varied parentheses, right? Yeah. And we need to times what? 2 times n because the length is 2 times n, right? So, but we can drop the constant, right? Look, we can drop this constant. So the overall complexity is O(n) times 2 to the power of 2 times n, right? Okay? That's a lot, yeah? That's a lot, right?
Yeah.
Okay, so what's the problem of this one?
Is that it's too
Slow. Why is it slow? Because we know that the beginning, can it be a closing bracket?
But if it's start with a closing bracket, it's definitely not.
It's definitely no. That's the problem, yeah? So we know, in some cases, we already know that no matter what kind of the possibilities come afterwards, it's still invalid parentheses, right? Yeah? So there's no way. Look, how many possibilities of these? There are a lot, right? But once we know it's a closing parentheses, do we need to generate all of those and check again? No, right? So because we are wasting time here, that's brute thing, right? So we can use the backtracking, which is the depth search, and then we don't continue exploring the past. If we found out that the current settings do not lead to a valid configuration, right? Do not current configuration do not lead to valid solution, right? Then we don't spend time doing that. Then we just backtracking, yeah? Backtracking. What's backtracking mean? Backtracking.
Like backtracking.
Yeah.
Like
So in order to do this, we can define a function. Yeah. Okay. Let's do this. Define what? Let's say. Let's call it depth search. Right?
depth search.
Okay. Then we obviously outside we have this answer. Answer equals the bracket thing, the list of empty solutions. And now we need to remember the current solution, yeah, current string, current part of the valid parentheses string, so we call it current, right? And then the current number of the opening parentheses, and then the closing parentheses, yeah, closing. Okay. Okay, so look, so at the beginning, we want to call this function with empty, yeah, because currently at the beginning we don't generate any parentheses at all, right? And then what should I pass with the second parameter and third parameters?
Open.
And closing. What's the number of the opening and closing?
Opening and closing.
At the beginning, do we have any?
No.
So what's the number we should put here?
0.
Yeah, 0 opening and 0 closing, okay? Okay, now, if the length of current, okay, if this string, yeah, Eric, look at me, equals what? Equals, remember we know there's an n, yeah, we know this n here, right? So what?
0.
No, the length, if the current length is equals n times n plus n, what does it mean?
N times 2. Is that technically n times 2?
Yeah, n times 2. Then this is a very parentheses, right? Yeah? Then we can answer dot append current, right? Yeah? Does it make sense? The depth of search. If we already know, actually there is something here. If the current string has the length of the 2n, we still need to check if what? Then we can append it. Answer dot append current. Can you tell me what's this? If what?
Opening and closing?
Opening and closing what? Opening what? Closing. For a very parenthesis, opening.
No. Wait.
Opening and closing. What are the?
Smaller?
What? For a very parenthesis, I'm saying. For a very parenthesis, what's the relation number of the parentheses? What?
Equal.
Yeah, equal. Right? Yeah. If the length is the final length, right? Yeah. If we want to generate three pairs of very parentheses, and the length is 6, right? That's what it means. The length is 6. Then we need to check if there are 3. Yeah. If there are 3 opening or 3 closing, right? And 3 closing. Another way of doing this is if opening equals n, and what? And what? Closing equals what?
And closing equals.
If opening equals n, closing equals what? Come on. Opening. Sorry? Opening equals closing. Another way of writing this is if opening equals n, closing equals what? Come on!
Opening. N.
N, come on. Opening equals n, and closing equals n, right? It's the same thing as opening equals closing because the length is n plus n, right? Right?
Column.
Okay, column. Good job. Okay, so now, if not, then we need to return here, yeah? Because the length is already maximum length, yeah? There's no point to continue. Look, if what? This is the condition. If in what cases I can search for current plus opening bracket and then open plus 1 and closing. In what cases? Okay, so this means I want to try next one with the opening bracket, right? So in what cases?
The closing bracket.
Yeah, I know, but in what cases I can try the next one as opening bracket?
If the opening is smaller than the closing. Wait.
No. In what cases I can put the opening? No. Okay, another one here. You think about if what, and I can try the closing. Current plus closing, yeah?
Closing.
Open, and then what should I put here?
Closing.
Closing what?
Add. 1.
Yeah, okay.
Oh yeah.
Okay, so in what cases I can put the open?
Closing.
If closing what?
Huh.
If closing what? Huh?
Smaller. Bigger.
So look, let's try this. If this here, there are 2 opening and 2 closing here, right? Can I put a closing here?
No.
Why is that?
Wait.
Can I put a closing?
Equal.
Yeah. Now opening equals closing, and can I put a closing here?
You need to put a.
Opening, right?
Yeah.
Then I cannot put a closing. When I cannot put the closing when the opening is what? Is smaller or equal than closing, am I right? Does it make sense?
Then how come you just can put it opening here? Like, so you need to always put it here.
No. What I'm saying is the current is equal to that. And I can put a opening, that's for sure, yeah? At any cases, I can always start with the opening. There's only one condition, I cannot start with the opening. Why is that? What's the maximum number of openings can we generate in this particular case?
All of them.
How? What? What's the maximum? The number?
All of them.
No. N, yeah?
Yeah.
Okay, so if opening what?
If opening is smaller n.
Yeah. If opening is smaller, then obviously I can do this, right? It's nothing to do with the closing, right? Because at any point I can start with the opening, alright? Yes? Got it? Can you find an example that I cannot start with the opening? Yeah? Ryan, are you alright? Are you alright, Ryan? Okay, for this closing, how can we do this closing? I mean, if the opening, what?
I think
What?
it's not closing.
Yeah, so in what cases we can start with the closing?
Open.
What? If open and close, what condition? If open,
Bigger.
yes, why is bigger? If
Greater.
open is bigger than closing, then we can do the closing, yeah?
Greater.
Yeah? Look, if there are two open and one closing, I can start with the closing, yeah? Alright?
Yeah.
Or the
Make
opening.
it equal.
Yeah, or if open is equal to the close, then I cannot start with the close, right? Because as long as I start with the close, the balance will fall below 0. It will be negative, it's the invalid, right? Got it? Yeah? Okay, so in this case, we can just do this. So it will be a lot faster than the brute force thing, yeah? The time complexity for this one is a bit tricky, okay? You don't need to, it's out of scope, right?
Oh, blah, 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 blah.
Yeah. It's very complex. It's 4 to the power of n divided by square n. Yeah, it's quite complicated. It's mathematics. It's roughly the Catalan number, C2n. Yeah, so it's quite complex. I can talk about this the other day, okay? But this is far better than what? Than what's the beginning? To the power of 2n times n, right? Yeah, this is far better than this one, okay? Because
This one has a times and this one has a divide.
yeah, this is exponential.
yeah.
Look, this is exponential. Yeah, yeah. Why this is better? Can you explain to Daddy that why this is better than?
Because the time complexity.
Yeah, and why this has a better time complexity? I mean, a faster time complexity.
Because if it begins with a closing bracket, it immediately is.
It's not valid, then we don't need to try, right?
Yeah.
So for this one, is that we don't generate all possibility. But for the first approach, a brute force thing, how does it work? We generate all possibility and we check each possibility, right? Let's take forever, right? That's going to take a much long time. Then we only generate the parentheses when there's a potential to be a valid parentheses. When we start with these closing parentheses, there's no way to generate all kinds of possibilities here, right? Because no matter what kind of configuration here, this setting does not give you a valid parentheses, right? Am I right? So you save lots of time here, right? It's like a binary tree, right? Eric, it's like a binary tree. So what does it mean? Look, at the beginning here, nothing here. You can generate open parentheses. You can generate a closing parentheses. But here we don't need to do this, right? Because this branch we don't need to explore. But here, opening bracket. Can we generate opening bracket? Yes. Can we generate closing bracket? Yes. And here, Can we generate opening bracket? Yes. Can we generate closing bracket?
Wait, no.
No, right? Right? Look at this branch, this tree, subtree. Yeah, we just don't visit it. Yeah, we save time here, right? You see? That's the depth search. Brute forcing depth search is try to visit every branch, right? And the backtracking is what? It's the depth search, but I don't visit those useless branch. Alright? Let's go back at backtracking. Okay? Alright? Yeah? Yeah, because I just found out it's useless visiting here, and then why should I keep visiting here, right? I can just go to the valid branches. Am I right?
Made it number 8.
Okay, so that's it for today. Thank you. See you. Bye bye.
Oh, bye bye.